Mechanical engineering. At the outset, I thank the organizers for inviting me as a resource person for this particular session. And this particular talk is related to the concept of biodiesels. Yeah, prospects of biodiesel as a fuel for sustainable power generation. So here I am Prashant Revankar from School of Mechanical Engineering, Keli Technological University, presenting my views on this particular topic. So basically, my discussion here would be revolving around these important points. I'd like to address on what is sustainability. Major part of my discussion would be on sustainability. Later on, I'll explore some concepts associated with biodiesels and to just see if biodiesels are sustainable or not. I have two research case studies through which I would like to highlight my point about the biodiesel being a sustainable fuel for the power generation. So here I go about this particular presentation. With your permission, for the purpose of having a good bandwidth, I'll switch off my video and I'll be presenting my presentation here. As you can observe from this particular slide, we see our Mother Earth, the home for mankind for several generations. And it has been a congenial place for human existence, mainly because of its habitable nature. It's a good climatic condition, all support features what life require to flourish. So that is how Mother Earth has provided all our basic requirements, not only to the human race, but to the huge diversity of life that has existed on this earth since a very long time. And now let us just observe one instance how the population of the human race is growing. As you can just observe from the population clock, that we will be close to 7 billion in a few, maybe in a span of 1 year. So why this particular balance between the resources what we have and the growing population? That's the main concern we have to address the issue of how we make our existence on this earth good. So that's the basic question what arises in our mind, that we can have a sustainable development on this planet earth by means of adopting certain principles. So then what does sustainability mean? Sustainability basically means the practice by which we do a minimum impact on the environment, and with this minimum impact on the environment, we will also be able to meet out our desired goals. So we'll be able to have employment for all people, and we'll also be having a good quality of life. We'll have all the basic requirements of life. So that can be obtained by means of developing a harmony between the environment and the development. So that is how sustainability is a practice by which we will not curtail the growth, but we'll also be protecting the environment. So this is how we have our biosphere. We have large species consisting of plants, insects, unicellular organisms. We have advanced animals, mammals, all these diverse group of organisms form this beautiful earth. And this particular point is to be noted by the human race, that earth is not the gift only for the human race, but we also have to support other forms of life. So we cannot just uh, destroy the other forms of life to make ourselves comfortable. So that would be going against the nature, because whatever form of life we are having has been created with a reason. So therefore, living in harmony with the different forms of life what we have on earth is the basic principle of sustainability. So with this particular backdrop of sustainability, I'd like to just introduce the basic concept of Dashavatara, what we have been knowing since our childhood. So this basically depicts the various forms of life and how we respect the different forms of life by giving them the role of deities. We have the Matsya Avatara, we have the Kurma Avatara, we have the Avatara in form of the boar, we have Narsimha Avatara and different avatars that we study in our mythology. This basically highlights how we are in harmony with the nature. And with this particular concept, I extend further, why do we require or how do we attain development? Energy is an important part of development. So therefore, as we can see, we require energy in different forms and we need it for our requirements. We need it for vehicles. We need it for running the industries. We need it for our recreation. So this way, life without energy cannot be imagined. So therefore, energy has been an integral part of our day-to-day life. So now, the quest of energy has made human beings to explore for different resources. For example, we try to generate electricity from nuclear fuels. We also generate electricity from coal. We also generate electricity from wind. So this way, ever since the inception of the human race on this earth, we have found that man has been exploring different ways to produce energy for his basic requirements. So that is how we see energy and development are interlocked, or they are closely connected. And further, as I just highlight here from this particular slides, we use different forms of energies, and we have a lot of physics that we have developed, or scientific development has been made in different areas to explore or to harness that form of a resource to generate electricity. So we study the nuclear physics, where it was understood that by means of splitting the nuclei, we can have a large amount of energy generated. So that gave rise to what we call as the nuclear fission reaction, nuclear fusion reaction. So this way, man has always been curious to understand the intricacies of nature and then try to use these resources for his existence or for his benefit. So that is how this particular slide explains you about the different forms of energies and how these different forms of energies can be explored to meet out our energy needs. And as we see here, nature has bestowed upon us various forms of energies. The energy in the lightning is of such a large magnitude, but it happens in a small instance of time that man has not been able to tap this form of energy. Similarly, scientific advancements has made it possible for us to generate electricity and then use it for illumination purpose. And similarly, the other part of the slide shows you the heat energy that we use for cooking applications. And we have also explored the different elements that constitute the periodic table. And then we are trying to explore about how each element can benefit our requirements. And this is how I group the energy sources into two main categories: the resources which are connected with nature and which do not require a large time to get re-established or replenished. So this is what we call as the renewable source of energy, and later on we are having the non-renewable forms of energies, which are again derived from nature. But these natural resources are of such a form that the nature does not have a cycle which quickly replaces these forms of energies. So non-renewable energy sources are the other segment what we find. Basically, man in the earlier part of his existence depended mainly on the renewable energy sources. As we found scientific development and we could find the energy content available in coal, oil, and the other things, we tried to explore for these resources. And the current situation, what we find in the present world is that we are dependent more on the non-renewable energy for our needs. So therefore, this has not resulted, or this has in turn disturbed the harmony with the nature. So therefore, the exhaustive or extensive use of the non-renewable energy sources has resulted in serious environmental degradation. So that's the main concern, which has led to a situation where we have to again question ourselves whether we should continue harnessing these non-renewable energy sources like coal, petroleum, and other sources, or do we have to again go back to nature and adopt the eco-friendly renewable energy sources. So that is how I was just highlighting about the concept of sustainability. How do we make the existence of life on this earth sustainable? So now the question arises, which form will go in for maintaining the sustainable relation with the environment? I think without any hesitation, we find that the renewable energy sources will lead to a more sustainable development, whereas non-renewable sources are going to cause a lot of climatic hazards. So moving ahead, you can just observe the various forms of renewable energy sources, what has been highlighted in this particular. And as you can see here, with a large population, close to 7 billion, we cannot totally stop the developmental activities. So the industries are required for us, and the industries in their current stage are putting a lot of pollutants to the environment. So thereby bringing about some undesired changes in the environment. So which is totally going to change the face of the earth. So therefore, we have other options. We can explore the renewable forms of energy like the wind or the solar energies, which can be a very good substitute for the oil reserves or by means of using other fossil fuels. So that is how we have got a quick representation of the primary energy demand and the electricity generated by our country. So as you can observe, so this is the data, slightly old, 2018-19 data. Again, we find the major part of it contributed by thermal, small part of it by nuclear energy, and that is how we can also observe the data of how there is a shift from the fossil fuels towards renewable energy sources. As you can find from this particular graphic, that renewable energy constitutes 22%, and hydro contributes around 12.9% of the total energy that is produced. And here again, we have got the data pertaining to the cumulative installed capacity of the generation. And this is basic slide which shows about how coal is formed. And as I just mentioned, coal is a non-renewable form of energy because it takes a large time for the nature to replace it. But however, coal is available in large quantity. That is the reason the human race has been exploiting this particular resource for the energy needs. And that is how we observe the formation of coal. The natural gas is another form of the non-renewable source of energy what we obtain from Earth's crust. And here we have got the nuclear fuels, which also constitute the non-renewable form of energy, or we broadly classify it as the conventional energy sources. And similarly, here is one very important slide which totally changes our outlook of how we are going to use energy and how we are going to build a balance between development and our energy needs and the environment which is connected in this particular loop. And this particular slide shows about how we can go green, or we can adopt some nature-based energy sources, so that we will build a particular developmental activity which does not cause a major hindrance to the problem. As you can see in this particular uh, graphic, which shows a highly polluted city, and the exhaust that comes out from an automobile is basically carbon dioxide, which is considered to be a greenhouse gas, which results into excessive temperature buildup in the Earth's atmosphere, leading to climatic heating up of the Earth's atmosphere, and climate change and global warming are the serious consequences what we observe. So now this is how we can change our strategy of how we use the resources. And as you can see, the 3 R's in the sustainability cycle: reduce the need, reuse the resources wherever possible, and also adopt the strategy of recycling the resources. So this is a basic concept what we use in our Swachh Bharat Abhiyan, where we try to recycle the waste, and we will also be using the waste that is generated from our cities in order to generate some energy, and that is how we are adopting a particular strategy by which we conserve our resources. As you can see here, an old pair of shoes is being adopted for growing some plants. So that is again how we change our attitude in using the resources, so that our future generation will not be deprived of the requirements. So that is how they aptly say that the earth what we are now where we are living is not the gift for us, but it is the asset what we have to transfer to the next generation. So that is how we have to take care of Mother Earth, and then we should hand it to the safe hands of the next generation. And again, some visuals which again highlight about how the resources can be utilized. Just putting the waste in the environment can lead to serious environmental problems. So therefore, segregating the waste and then recycling or maybe reusing them at appropriate instances can result in minimizing the burden what we are putting into the environment by means of the developmental activities whatever we observe in the present. So therefore, sustainability is about using the resources in a more conservative manner so that they have a minimum impact on the environment. As you can see, we can clearly identify these are all the household consumables, or these are the equipments, or these are the products what we use in our day-to-day life. So just disposing them can make our city unclean. So therefore, measure where we segregate them, then use it, and make use of the concept of what we call as the concept where we extract something useful from the waste. So that is how we can change our attitude of developing this particular, using the resources. As you can see here, another graphic which shows how the adoption of renewable energy sources can conserve the fossil fuels like coal and other resources. Definitely, we cannot have a situation where we can totally switch over to renewable energy sources, because they have some inherent drawbacks. So we also require the non-renewable energy resources like coal and petroleum in our energy mix. So therefore, currently as they are depleting in nature, our strategy should be to conserve them. And so based on that, we have the strategy what we have to adopt. And please note that Government of India has an ambitious plan of switching over to the renewable energy sources, as we can observe from the various programs supported and implemented by the Government of India. And we have been seeing a lot of very good initiatives taken by the government in this particular direction. It's not only our country, the entire world is now moving towards using the nature-based energy sources. So that is how we find the adoption of the renewable energy systems for our day-to-day. And this is how we can see India's renewable energy target by 2022. So there is an ambitious target of having 175 gigawatt of energy coming from the renewables, and so major part of it is contributed by solar energy, and these are the different options we are having for the energy mix. So now that is how we can also see the power breakup. India still relies heavily on the thermal power, but it has gradually been shifting towards renewable energy source. But still, the thermal energy has been a major contributor to the energy mix, and this is what we find, that we are targeting at 225 gigawatt of renewable energy capacity by the year 2022. And this is how we have got the solar energy systems which contribute. Yeah, this is one particular example where educational institute has installed 1.2 megawatt of the solar energy to meet its energy needs. So this is how the government has been promoting the use of renewable energy for all the organizations, be it government offices or educational institutes. It is heavily promoting the use of the renewable energy sources. So that is how we are having targeted installation capacity of 175 gigawatt till the year 2022. And here, this particular slide shows the nature-based energy that is available to us, and it is evident from the statistics that solar energy per year is of the magnitude of 1.56 into 10 raised to 18 kilowatt hour, whereas the yearly energy demand worldwide is of the magnitude of 1.11 into 10 raised to 14 kilowatt hours. So that means solar energy exceeds the amount of solar energy that we receive is much higher compared to the the total energy that we are going to consume. So some statistics put it something like this: the amount of solar radiation striking the earth over a 3-day period is equivalent to the energy stored in all fossil energy sources, and sun provides enough energy in 1 minute to supply the world's energy needs for 1 year. And finally, we find that the solar energy striking to the earth in a day can be used by 7 billion humans for 27 years. So that basically shows the abundance of the solar energy that is provided to us by the nature. But if at all this is the situation, then can we totally adopt solar energy for all our energy needs? Yeah, there are some technical challenges which come in the way of total switchover from the renewable energy to from the non-renewable to the renewable energy sources. So that is how some technological interventions are required in order to make this possible. Some innovative methods of extracting the energy from the sun, and some very efficient energy storage devices can make it possible to solve the current energy needs, because the current generation cannot go without energy, because so many industries, so many domestic energy requirements we presently have. So therefore we cannot imagine a situation where we do not use energy on a particular day. So therefore we cannot stop using energy. At the same time, we cannot also harm the environment for the reason we are producing the energy. So therefore, we have to strike a balance between these two. So I think all nations in the world have agreed upon that we should gradually migrate from the polluting form of energies to eco-friendly energy sources. And that is not only about choosing a particular source of energy for our requirements. It also has a great amount of effort also has to be taken up in order to reduce our need. So therefore, if by some means we can conserve energy and bring down the energy need, so I think that way we can also make a great help to this particular environment. So now here, this is what the world over they have agreed upon, that if at all we have to make the earth to be habitable by the next or the future generation, we have to seriously work upon how we build a harmony between development and the energy use pattern or the resources what we are harnessing from the nature. So United Nations has drafted the 17 sustainable development goals, which cover almost all the human activities, or all spheres of our existence are being covered by these sustainable development goals. So just to sum up whatever I have presented here on sustainability, sustainability is about how we make our neighbor to live cordially with us. So how we can see the entire human race to lead a happy life where they are not deprived of the resources. So let us quickly go through these 17 sustainable goals what the United Nations has identified. As you can just observe from these particular slides, it says no poverty, zero hunger, good health and well-being, quality education, gender equality, clean water and sanitization, affordable and clean energy, decent work and economic growth, industry, innovation and infrastructure, reduced inequalities. Goal number 11 says we have to have sustainable cities and communities. We should have responsible consumption and production, climate change. There is a goal on how we protect the life below water, life on land. We ensure peace, justice, and strong institutions in the world, and how we build partnership for the goals. So because we as the human race have to depend upon one another. So we cannot have a situation where United States or United Kingdom or any other country of this world can live a solitary or can have a solitary existence. So they have to depend upon one another, and that is how these 17 sustainability goals or sustainable development goals are bringing about some harmony in the world. So now if you closely observe the 17 different aspects that are being highlighted in these United Nations defined sustainable development goals, you can clearly observe they are again connected to our day-to-day life. So no poverty would mean that we should have a system where the lower sections or the part of the society uh, will not be deprived of the resources, or uh, we should see that the resources whatever are provided are distributed in an equitable manner, so that no individual on the face of the earth suffers from poverty. Zero hunger again indicates that we give ample opportunity for all individuals to have their requirement of food, good health, and well-being. So this is how each and every aspect discussed here in the 17 sustainable goals will be closely connected to our day-to-day activities. So that is how the sustainable development goals are also termed as the Millennium Sustainable Development Goals are designed by the United Nations in order to make development reach each and every part of the world. So that's how I've just tried to highlight these in slight detail about how we reduce poverty, how we adopt strategy for obtaining clean water and sanitation, how we maintain gender equality, how we promote quality education. So that is how this goal number 7 is about affordable and clean energy. So this is one important goal from the current discussion what we are having here on biodiesel as a sustainable fuel for energy generation. So now what can be done so that the energy that we generate is clean and it is also affordable. So now people say that the price of petrol and diesel is increasing at an alarming rate. So again, this is not what people wish to have. So they wish to have the energy available in an affordable form. As engineers, what can we do in order to make the energy affordable? So one approach would be that we use the energy in a conservative manner. So instead of using individual vehicles, we could switch over to public transport systems, thereby the overall consumption or the oil bill what our country is paying to the or spending as the foreign exchange can be reduced. So that is how government of India has also taken up several measures in order to realize the sustainable development goals. And that is how we can see sustainable cities and communities is what we cover in our initiative of Swachh Bharat Abhiyan, where we try to collect the waste generated by the cities and then dispose it in a sustainable manner so that it does not create inconvenience for the other people residing in the city. So now that is how the sustainable development goal also covers what action do we take so that climate change and some things which are detrimental for the existence of life on Earth. Life should not be under threat. So therefore, it is the initiative supported by all the major countries of the world so as to make our Mother Earth as a safe place for the future generations. So that's about the sustainable development goals. Now coming to the next point of my discussion here, sustainability is about judiciously using our resources in a way that does not harm the environment. So in this particular direction, we have got the biodiesel, which is the central theme of my discussion in this particular presentation. So we have been seeing the different requirements why we are using fossil fuels. When I say fossil fuel, it includes petrol and diesel, and how biodiesel is different from the petrol and diesel what we are using. As you can just observe from this particular biodiesel cycle, biodiesel is obtained from a plant source or an animal source for which the sun is the primary input energy provider. Through the process of photosynthesis, the plants are going to produce oil seeds, and these oil seeds are subjected to a chemical processing by which we are going to obtain crude vegetable oil, and this crude vegetable oil is going to be subjected to a process where we try to modify its properties and we make it to a quality which is resembling the characteristics exhibited by the petrodiesel that we obtain from the Earth's crust. So the end product what we obtain from here through the transesterification process is termed as the biodiesel. So it has properties similar to that of diesel, and as it is extracted from a plant source or living source, we call it as biodiesel, and then we can use it for as a substitute for the conventional diesel fuel. And please observe, apart from this particular biodiesel, we also have alcohols which are again obtained from the plant sources, which aid in the process of the transesterification process. And as a byproduct, the transesterification process leads to glycerol as a byproduct, which we can use in industry. So now we can use it for food industry, cosmetic industry, or the different places. So now why glycerol is obtained in the process of transesterification? Because the crude oil or the vegetable oil what we obtain is having a very high viscosity. So in the present form or in this form of the crude vegetable oil, we cannot directly use it in the vehicle as a fuel substitute. So therefore, we subject this particular crude oil to a process of transesterification and thereby make it have properties which are in par to the properties of diesel fuel. So that's how we use it for our transportation needs. And further, the carbon dioxide that or whatever gases that are produced by the vehicles will produce carbon dioxide, and this enters back into the cycle of photosynthesis. So that is how we observe that biodiesels are carbon neutral, because the diesel what we obtain from the earth will not form a closed loop where the end products that are formed will be reused in the cycle. But unlike here in the biodiesel cycle, you can observe the carbon dioxide molecule rejoins the cycle, and that's how it becomes a sustainable practice of producing biodiesel and then using it for our day-to-day energy needs. So that is how this is the basic difference. The biodiesels even have a similar products that we find in diesel, because again biodiesels can lead to CO, NOx, particulate matter, smoke. All these emissions will also be present in biodiesel, but one advantage is that they again get recycled by the photosynthesis process. But somehow research is again underway to see that we minimize the pollutants that are produced by the use of biodiesels or the diesel fuel. So this is how, after the concept of sustainability, I have the biodiesel cycle to highlight the point that biodiesels can lead to an energy generation cycle which is a sustainable cycle. So now uh, that is what we have here. And how is our national policy on biofuels? Biofuels is a broader group of the derivatives what we obtain from the bio sources, and biodiesel is one of the fuel under the broader umbrella of biofuels. So here an indicative target of 20% blending of ethanol in petrol and 5% blending in biodiesel in diesel is proposed by 2030. So that means government of India is trying to promote the use of biodiesel. Please observe, we cannot use 100% biodiesel for our transport needs. They have to be used in blended forms. So when it comes to ethanol, it can go up to a 20% blending, and biodiesel is targeted at 5%. And further, the policy also states that with the thrust on advanced biofuels, the policy indicates a viability gap funding scheme for 2G ethanol biorefinery of 5,000 crore in 6 years, and an additional tax incentives, higher purchase price as compared to 1G first generation biofuels. So again, they are bringing about some changes in how we can make a larger use of the biofuels as a replacement for the fossil fuels. And please note, there are also initiatives taken in, as you can just observe, categorization of biofuels into basic biofuels and advanced biofuels. That is what I was just referring here as the first generation and the second generation biofuels. The second generation includes the algae, the drop-in fuels, algae-based third generation. That's how they have the first generation, second generation, and third generation biofuels. So increased scope of raw materials for ethanol procurement by encouraging intermediate sugarcane juice, other sugar containing materials. So that's how we have a lot of initiatives taken up by the government in order to promote the biofuels. And biodiesel is one particular area of the biofuels. And please observe here, biodiesel production to be encouraged from non-edible oilseeds, used cooking oil, short gestation crops, and development of supply chain mechanism. So that is how the policies have been designed in such a way that you make them sustainable. We cannot extract the oil from the edible oil seeds because it can create some problem associated with the food grains. So therefore they are encouraging non-edible oil seeds, and they also stress on adopting cooking oil. I mean the used cooking oil, after you use the cooking oil for say 2 or 3 cycles of frying, then it will be having some properties which will not make it fit to be further used. So therefore that's what we call as waste cooking oil. So you have a large potential for waste cooking oil generated by the hotels and other firms which are into cooking industry. So therefore, there is an initiative towards developing the biodiesel production using these cooking oils. Short gestation crops are the one which give yield in a shorter growth duration, and the development of supply chain mechanism basically refers to how you are developing an inclusive policy so that we will reach the last person. It should not be a situation where you have got a supply chain where the primary investor takes up all the profit. So a sustainable system would be one where you are going to reach the last person in the cycle. So inclusive development refers to situation where you create more employment out of the process. So therefore, it leads to meeting out the other connected sustainable development goals. Thrust on research development and demonstration in the field of biofuels, feedstock, advanced conversion technologies, and identified feedstock. The setting up of Biofuel Coordination Committee under Ministry of Petroleum and Natural Gas and Working Group on Biofuels. So that is how our government has taken a lot of initiatives to work on making biofuels as a sustainable source of energy. As we are spending a lot of our foreign exchange in getting oil imported from the oil-rich countries, these initiatives can definitely help minimize the foreign exchange that is flowing out of our country, and also develop a mechanism where our country will prosper because of the employment generation that can happen because of the initiatives what the government is taking. So that is again the other phase of sustainable development. It is not only physics, it also involves a lot of other strategies, other decision making, policy making. So in all, we see that the benefits will reach the larger group of people. So that is our national policy on biofuels. And similarly here, we have the major biofuel contributors as ethanol and biodiesel. The consumption impact, the biofuels are renewable sources, reduced CO2 emission, improved air quality, decreased pollution. So these are the points what we can easily understand if we look into how biodiesel can benefit us. And the production impacts, competition for land, water, and resources. Now, if we have a biodiesel or a biofuel strategy that apart from growing food grains, we also use a part of our land towards growing oil seeds that build our biofuels, then again there would be a competition for land, water, and other resources. Land use changes, loss of soil organic carbon, impaired soil productivity, greenhouse emissions, environmental pollution. So these are all the practical implications what are to be taken care when we devise a particular policy. Yeah, this is about how we make biodiesels as a sustainable source. Or this part of my discussion has covered about what is sustainability and a small insight into what is biodiesel and how biodiesel qualifies to be called as a sustainable fuel for power generation. So now here I am going to present a research case study where we have two segments in this part of the discussion what we make here. The first part of it highlights on the production or the generation of the vegetable oils. This particular research carried out in our university was for a batch size of biodiesel production in a lab scale. So this is how I will quickly highlight about some desirable properties of the vegetable oils and how these properties are essential to qualify as a fuel substitute for diesel when we use it for operating an engine. So this is how I quickly move on to highlight some important properties of diesel and vegetable oil. As you can see, the structure of diesel compared to the structure of the vegetable oil. Both diesel and vegetable oil are hydrocarbons. They have carbon and hydrogen as the major constituents. But one important observation you can make from the two structures is that apart from C and H, we also have oxygen in the vegetable oil molecule. So this is how we find that vegetable oils are having a different chemical structure, and through some chemical processing, we transform the vegetable oil molecule to a similar molecule what we have for the biodiesel. So that's how we have got the ideal diesel fuel molecules are saturated non-branched hydrocarbon molecules, as we clearly observe from here, with carbon range numbering from 12 to 18. So because there would not be a fixed chemical equation for diesel, as we say that methane is CH4. We cannot have a precise, it's a complex mixture. Diesel would be a mixture where carbon atoms would be varying from 12 to 18. Whereas vegetable oil molecules are triglycerides, generally with no branched chain and different lengths and different degrees of saturation. This is an unsaturated molecule. Saturated molecule is unsaturated molecule. Vegetable oils have substantial amount of oxygen, as I just highlighted here. That is the reason they have higher viscosity, lower calorific value, lower cetane number, higher flash and fire points. So these are the basic observations we make from the chemical structure of the two fuels what we are having here. So now the presence of oxygen in the vegetable oil will make the calorific value lower as compared to what we have for diesel, because carbon and hydrogen both are going to contribute towards releasing heat, whereas oxygen being only a supporter of combustion will not be adding any heating value to the fuel. So therefore the weight contributed by oxygen does not add any heat. So therefore the vegetable oils have a lower calorific value compared to the diesel fuel. They also have higher viscosity because of their chemical structure. The viscosity of vegetable oils, we'll see in the later slides the values. So that's how we have these two different chemical structures which explain you about the diesel fuel and the vegetable fuel. And a quick overview of the vegetable oils. Present a very promising alternative to diesel oil since they are renewable and have similar properties. So because we have large area where we can grow the renewable fuel, so therefore they state it as a promising alternative, offer almost the same power output and a slightly lower thermal efficiency when we use in diesel engine. Reduction in emission, engine emission, is a major research aspect that we find for the vegetable oils. Alternative liquid fuels must be technically and environmentally acceptable and economically competitive. So there's an important point here about the use of vegetable oils. If the vegetable oils again pose environmental issues, then there would not be a good replacement or an alternative for the diesel fuel. So therefore, a thorough property investigation has to be made before we invest on a particular type of a vegetable oil. Vegetable oils are compared to diesel fuels have acceptable heating value when subjected to the process of transesterification, where we tune them to values close to that of diesel, then we can have acceptable heating value. But heating value is always less than what we have for diesel fuels. So vegetable oils are triglycerides, which are esters of long fatty acids and polyalcohol alcohol glycerol, have large molecules with carbon, hydrogen, and oxygen. This oxygen is an additional part what we do not find in diesel fuel. Have comparable energy densities and cetane number. So that's how we have got a few other properties associated with vegetable oils. The important thing I would like to highlight is the presence of oxygen in vegetable oil raises the stoichiometric air fuel ratio. The carbon residue of vegetable oil is higher than that of diesel. So these are a few important aspects of the vegetable oils what we take into account for. A number of vegetable oils have been tested all over the world to evaluate the performance in diesel engine. As you can just observe, we focus on using the vegetable oils which are not directly used as food items. Neem oil, palm oil, honge oil, rapeseed oil, coconut oil, cotton oil seeds, jatropha oil, mahua oil, rubber seed oil. These are some of the options, but again, all of these options may not be suitable for large production of the biodiesels. For example, you cannot use cotton seed oil because it may have some medical applications. So rubber seed oil. So that's again a particular discussion on whether food is a priority or fuel is a priority. So definitely coconut oil cannot be used as a vegetable oil because priority would be having it as a food item. So that's how we have it. Studies have revealed that some of these oils have can directly substitute diesel in electricity generating stations and irrigation with no modifications required. Such oils are commonly referred to as straight vegetable oils. Vegetable oils that do not require major processing before being used in the before being used as fuel. They are called as the straight vegetable oils. Some of the properties will just quickly make a comparison. The important properties include density, calorific value, cetane number, viscosity, flash point, carbon residue. We have this particular representation for diesel is the benchmark where we're going to compare with honge oil, jatropha oil, rapeseed oil, and the other versions. I'll just quickly highlight on the calorific value. Diesels has calorific value around 42 megajoules, whereas the various other vegetable oils are much lesser than the value what we have with diesel. Similarly, the cetane number, viscosity is one major concern what we find with the vegetable oils. And as you can just observe, viscosity is much higher. That's how we subject it to the process of transesterification to bring it to a lower value. So these are some important properties of the non-edible vegetable oils. And similarly, here we have got the different constituents that we find in the free fatty acid composition of the different vegetable oils, as you can just quickly observe here. Yeah, but this is again to make a comparison with diesel. Viscosity of the non-edible vegetable oils at 40 degrees centigrade. So, and please observe, these are the methyl esters, or these are the products what we obtain after the trans-esterification process. So hongia oil has a viscosity of 56 CST, whereas when we subject this to the trans-esterification process, its viscosity gets reduced to 5.6, comparable to that of diesel oil, which is 3. Jethropa oil similarly has the viscosity listed here. The process, these are all the vegetable oils after subjecting them to the trans-esterification process. So we would call these as vegetable oils, whereas these are called as the biodiesels. These are the biodiesels of the different vegetable oils what we obtain. And please note that the viscosities of the different grades of vegetable oils are no doubt higher than the diesel, but they can be suitable for operation on a diesel engine when we are going to use them in a blended. And similarly, the density of the fuel, different vegetable oils along with the biodiesels that we obtain from the vegetable oils, and similarly the calorific value that we have for the different. Yeah, this is where we highlight about the hongia oil has a calorific value of 35,800 kilojoules per kg after the trans-esterification process. Biodiesel from hongia oil gives us a calorific value of 36,120. Of course, lesser than what we have for diesel, which has 43,000 kilojoules per kg. And as you can see that different grades of the vegetable oils that we obtain vary in terms of their calorific values, and the resulting calorific value after the trans-esterification process are also of varying nature. So that is how these values will be some indicators for their feasibility as a substitute for the diesel fuel. Similarly, the cetane number for the different vegetable oils as compared to the cetane number what we have for diesel as a fuel. So that is flash and fire point. A few dot marks here are the one which we have not investigated in our lab, and similarly the fire point. Yeah. Now the challenges what we are having for using the vegetable oils, operational and durability problems associated with using vegetable oils, and how we can address these issues. When I say vegetable oils, they are the raw or the crude vegetable oils before being subjected to the trans-esterification process. So operational problem is the starting ability, ignition issues, combustion parameters, performance parameters. So experiments were conducted with crude vegetable oil as well as the vegetable oils when they were transformed to biodiesels. So deposition formation, carbonization of the injector tip, this would lead to the blocking of the injector hole, piston ring sticking, lube oil dilution, fuel filter plugging. So all these are the major issues what we observed by using the vegetable oils. And these vegetable oils were subjected to trans-esterification process, and then we had these problems were handled by means of heating, blending, or trans-esterification. So high viscosity, extremely low volatility, polysaturated characteristics. So these were addressed by these respective interventions that were done. So vegetable oils require trans-esterification for their conversion to biodiesel. That's the basic process what we have, where we transform the high viscosity vegetable oils into biodiesels as a renewable, non-toxic, containing oxygen, no sulfur, etc. Okay, this is one of the biodiesels what was investigated in our lab, which is fungi, also referred to as Fungemia pinnata, and these are this is the fungi tree, and these are the seeds what we extract from the pods of the fungi plant, and these are the methods of reducing viscosity, preheating of vegetable oils, transesterification, direct use and blending with diesel, emulsification, yeah, use of low heat rejection engine. These were all the experimental observations that were made. Yeah. Methods of preparing biodiesels. So now, how do we produce biodiesel? Biodiesel is different from the crude vegetable oil in terms of refined properties that we are going to obtain. So all these four different processes were investigated in the lab. Yeah, these are some of the observations we could make because of the presence of higher viscosity in the vegetable oils, as you can just observe from this particular representation. Why do we need transesterification? So these are the experimental observations, as we just highlighted in the other part of our discussion. Practical results show that direct use of the vegetable oils can lead to carbon deposition, wax deposition, injector tip getting clogged, and then so that's how we have deposition, carbon deposition happening in the injector of the diesel engine. Yeah, and chemistry of how transesterification happens, the triglycerides in the presence of a catalyst with methanol added will result in methyl esters. Methyl esters are the biodiesels, and this is the byproduct what we obtain is the glycerol. Yeah, this is the experimental setup that was being used for producing the biodiesel. Yeah, basically the process involves distillation process where the vegetable oil along with methanol and the catalyst are heated in the flask, round bottom flask, and simultaneously the mixture is subjected to a stirring by means of using the magnetic stirrer, and the vapors are separated out, and then based on the separated vapors we are keeping it for settle or separation of the biodiesel from the other glycerol. Then it's subjected to the ester separation and biodiesel washing, and moisture removal is also an important part where we separate out the leftover moisture from the biodiesel, and this is how we have all the three phases of the fuel processing. We can see the diesel, this is raw hongi oil, and this is the biodiesel that we obtain from the hongi oil. So this part of our discussion highlights on the production of biodiesel on a batch scale, and these were the different parameters that were taken into account during the biodiesel production. And these are some of the experimental results which highlight about the process of the transesterification process. These are the transesterification parameters. As we can see, the percentage conversion with varying amount of the catalyst that we add, and the varying amount of methanol that we are going to add. So that is how it clearly states that a 5:1 ratio is going to give us a greater yield, and that's the time what we have Okay, again, the temperature observation between how the viscosity of the three constituents are being compared, diesel, and what we have here is the raw Hongi oil, and in between the properties of raw Hongi oil and the diesel, we are having the viscosity of the biodiesel due to trans-esterification process comes closer. I mean, it has properties very much closer to that of the diesel fuel. And similarly, here you can observe viscosity of the blended fuels, how it compares with diesel. So here you can observe B100 refers to 100% biodiesel, and 20% of biodiesel and 80% of the diesel. So that's how 40% and 80% the viscosity of the blends is being compared here as a function of temperature. And here again, the different properties of the blends. So the question arises, why should we know the properties of the blends? Because we are using the biodiesel in a blended form. So that's the reason we investigated the properties of the blended fuel in different proportions. Yeah. And here the changes in the physicochemical properties of the biodiesel before and after trans-esterification. I mean, yeah, I think I should highlight this. Long-term storage of biodiesel is going to bring in some change in the properties. That is what is investigated through this particular representation here. Specific gravity marginally changes, and density almost remains same. So that's how we have made the investigation on storage of biodiesel and long-term effects of storage of biodiesel. And here we can just draw the conclusions from the research case 1, which highlights about trans-esterification of the Hongi oil. The quantity of catalyst and methyl alcohol used is crucial for successful reaction. Washing is necessary to drain away undesirable contaminants in the biodiesel. And we have 1% NaOH, which is a catalyst, and 5:1 molar ratio of methyl alcohol, 60 minutes and 60 minutes of the process time, and 65 degrees centigrade as the operating temperature during the trans-esterification process to be the optimum value. Non-catalytic supercritical methanol trans-esterification being a batch process results in faster biodiesel yield and uses no catalyst. So this is other way of trans-esterification. Microwave assisted trans-esterification being a continuous process can ensure continuous engine operation. So properties of Hongi oil, methyl esters and its blends with diesel were comparable to that of standard diesel. Yeah, these are some of the observations that were made as part of the study. So that brings me to the end of the first case research, which highlighted about the production of biodiesel and its physiochemical properties as compared to diesel. And the second research case study highlights about what will be the consequence of using the produced biodiesel in engine as a fuel. The main objectives of the study to study feasibility of Hongi oil and methyl esters for CI engine in single fuel mode and to optimize the injection time. So because the engine that is being supplied by the manufacturer is tuned to operate on diesel fuel. So now what will be the implication of using different blends of biodiesel instead of the standard rated diesel fuel? So we have made investigations, and these investigations are presented in form of the feasibility studies with respect to optimizing injection timing and optimizing injection pressure. Injection timing and injection pressure are the critical parameters which have a bearing or which have an influence on the overall brake thermal efficiency and the other parameters related to the engine. Let me quickly move on to the parameters that were investigated as part of this study. The brake thermal efficiency and the volumetric efficiency were investigated. Emission parameters included the exhaust gas temperature, the smoke emission, hydrocarbons, NOx, and the CO emissions were investigated. The combustion parameters included peak pressure and maximum rate of pressure rise, ignition delay, combustion duration, heat release rate. All these parameters were investigated. So why are these parameters important? These parameters are important for verifying if a particular grade of biodiesel would be operating good when it is blended with the diesel fuel. So that is how these investigations will help in order to ensure the usage of the biodiesel as a fuel. So these are the specifications what we have for the diesel engine. A single cylinder diesel engine, Kirloskar make, was used for our studies, and that's how we made our investigations. Yeah, this is the engine setup present in the IC engine lab. As you can see, the engine setup has provision of acquiring the data related to the operation of the engine. Here, the heart rate smoke meter, 5-gas analyzer, and this is the arrangement we have in order to make change in the injection pressure and the other parameters. So that is how we have got a computerized IC engine test rig with various facilities to measure the different parameters that are required to perform the engine testing, and we'll be running the engine at different percentage of the maximum rated capacity of the engine. So part load as well as the full load operation of the engine were investigated as part of the study that was conducted. Yeah, effect of injection timing was investigated taking different combinations, 19°, 23°, 27° before TDC, and injection pressure was varied between the limits 205 bar to 180 bar. For each load, airflow rate, fuel flow rate, exhaust gas temperatures, various parameters were experimentally observed. Injection timing refers to the angle, like the engine is tuned or manufactured for a particular injection timing. When we use the blends of biodiesel, so there is a requirement of some modifications that have to be incorporated so that engine again operates at a higher thermal efficiency. So now please observe here 19°, 23°, and 27° BTD means injection occurs at these angular positions, and we could do that by means of using shims provided at the base of the injection fuel. And what will be the change we observe in the performance and the emission characteristics of the engine when we do these tests? The brake thermal efficiency for various injection timings, 3 different injection timings were taken into account. So for 205 bar injection pressure, 80% load, you could see the influence of the injection timing on the brake thermal efficiency of the engine. So similarly, the smoke emissions recorded for similar operating injection pressure for standard diesel, hongi oil. This is the raw hongi oil, and the biodiesel of the hongi oil, what we refer as the hongi oil methyl ester. So this is how we could observe that the hongi oil gives the higher smoke emissions as compared to the other two combinations. We could see that the smoke opacity is lowest for the standard diesel, whereas the raw hongi oil and the biodiesel of hongi oil produces slightly higher smoke compared to the standard diesel. Similarly, hydrocarbon and the carbon monoxide emissions for 80% load with 205 bar of injection pressure with a constant speed of 1500 rpm maintained for the engine. We again find that the raw hongi oil has higher hydrocarbon emissions compared to what we obtain from the biodiesel of the hongi oil, or HOME, home, and similarly diesel has a lower emission relatively compared to the biodiesel. And similarly, the carbon monoxide in terms of percentage for the same fuel combination tested was observed like this. And similarly, the NOx emission. And the concluding remarks: it is possible to operate the CI engine with hongi oil without transesterification, but the performance of the engine will be poorer. Yeah. Further, there is a higher smoke emissions are on the higher side. So it is being quantified based upon the observations. 19 degree BTDC fuel injection timing is found to be optimum for the hongi oil operation. And similarly here we have the optimization of the injector opening pressure for the fuels that were tested. So now IOP between 205 bar to 280 bar was tested. Yeah. So now based on these observations, you could see that injection pressure was set. Yeah. These are the different spray patterns we are going to obtain. Yeah, it's the spray pattern what is being studied. Effect of injection pressure on hongi oil injection. Injection pressure is important because it is going to have some influence on the atomization of the fuel that we are injecting into the engine cylinder. So now the various observations that we can make here, how the brake thermal efficiency is going to be influenced by the injection pressure, and this is the observation what we have for the optimized injection timing of 19 degree BTDC for hongi oil, and the same is being compared with respect to the exhaust gas emission. Brake thermal efficiency will be somewhere around 28 or 29% for operation at 260 bar, and Similarly, we observe the exhaust gas temperature. Exhaust gas temperature of a higher magnitude is the indication of heat being wasted to the surrounding air. So therefore, it's not a desirable factor. So that is how we observe from the graph the influence of the injection pressure on Hongi oil injection. And here we observe the representation of the heat release rate, how the heat release pattern is going to change for the different values of the injection pressure we are adopting. For the fixed 23 BTDC injection time is taken in this case for the Hongi oil. Similarly, we can see in the subsequent slides cumulative heat release rate, and in this particular observation you can see how the smoke opacity is going to change for Hongi oil when operated at different conditions. CO and NOx emission. Yeah. The performance, emission and combustion characteristics of the engine under variable load conditions have been compared at the optimum injection timing for Hongi oil methyl ester and diesel. So now, as you can just observe, the comparison goes in this way for the three different values. 23 BTDC is what we adopt for standard diesel, 19 BTDC for Hongi oil, and 19 BTDC. The same is used for the biodiesel of Hongi oil, and the comparison with respect to brake thermal efficiency for various load conditions. 7 VHP or 7 kilowatt, or you can just observe here, we could run the engine up to 5 kilowatt rated capacity. Beyond that, engine operation does not happen. So here again, 23 BTDC for standard diesel, and we can see that standard diesel has again the highest volumetric efficiency as compared to the other two fuels which we want to compare. Exhaust gas temperature again happens to be lowest for the standard diesel condition, whereas the methyl ester of the Hongi oil shows some intermediate performance between the raw Hongi oil and the standard diesel conditions. So that's how we have various experimental results which highlight the operation of the engine with respect to again emissions, NOx, and heat release rate. Yeah, here ignition delay, cylinder peak pressure is being analyzed, and this particular graph indicates the effect of maximum rate of pressure rise versus the brake power for the different variations. Combustion duration, yeah, this is the variation of heat release rate for Hongi oil, methyl ester of Hongi oil at optimum injection timing. Yeah, experiments on neat Hongi oil at different injection. Yeah, so that is how I've got this particular presentation where I have tried to highlight on the process of how we produce the biodiesel, and also the process of how the biodiesel performs with respect to the performance characteristics, where we compare its feasibility with respect to emission characteristics as well as performance characteristics. So these are very important in order to ensure that whatever we gain, or it results in a situation where we can check the feasibility of the fungi oil as or any other biodiesel as a fuel substitute for the diesel. So these were the important results what we obtained from investigations. This is one small part of the work that is being highlighted, but lot of investigations have been done on biodiesels as a means for as a means of substituting the fuels, and all these investigations are necessary to ensure the feasibility of the biodiesel used as a fuel. Yeah, this is my part of the presentation. I think I have some questions placed in the chat box. Yeah, Devjit Mishra has to say, I think in 2050 there will be no fossil fuel. We should preserve some fossil fuel to show to our next generation. Yes, Mishraji, I think a valid point is made about the future of the fossil fuels. So now prediction about the exhaustion of the fossil fuel is again a matter where a lot of debate has been happening. We still see that the resource is quite abundant to last for a few more generations, but exploiting the resource would not be a wise proposal, because it also has some issues associated with the environmental degradation. So therefore, no doubt fossil fuels may be available to us for the next 100 years, but using them in the rate at which we are exploiting them would lead to serious environmental implications. So in that context, it is always a good proposal to switch over to cleaner energy sources. So that is how we have got the observations. Yeah, Harish sir has to say that among transesterification, supercritical methanol, microwave assisted process, which one is better to produce quality biodiesel? So again, it depends upon the size of the biodiesel which we are going to handle. It has been reported that transesterification happens to be a more feasible option compared to other processes, because they consume more energy compared the process. The amount of energy that is required in the other modes would be relatively higher. So in that context, transesterification has been practiced to a greater extent. Yeah, probably these were a few things I could just observe in the chat box. So now the floor is open for some discussions. You may please have your questions. Yes, please.
Participant, ask the question. Any query? Unmute.
Hello, sir. This is Vikas Uncle, chemical engineer.
Yeah.
My question is that it's on about the amount of or the quantity of water we use for washing and drying of the biodiesel prepared after the transesterification.
Yeah.
And that water, that composition is harmful, or that can be reutilized or recycled. Please speak.
Yeah, normally for our lab application, because to avoid the contamination, we used distilled water. I think that can be a good area to research, but the contamination that are induced, I believe, can be separated through a simple process of distillation. So reuse of the water that we use for washing will not be involving a tedious chemistry. I think it should be a straightforward process. But I'm not very much aware about the chemistry of handling the water that comes out after the washing process. I think we just put it to the drain without making detailed chemical studies on that. So you could please excuse me on this particular aspect. But there are no major chemical constituents that enter except for small part of the catalyst again, which gets separated, and somehow glycerol also gets separated in the process. Yeah, that is how I would put it.
Sir, one more part is
Yes,
like the catalyst what we use,
yeah,
that maybe NaOH or KOH,
yeah.
that presence of that material in the final ester molecule or the biodiesel molecule, how much like what are the consequences of that composition on the engines or the parts of an engine?
I think as a we have a process where we separate the catalyst. The catalyst will not go into the final biodiesel whatever we produce. So there are intermediate processes where we separate out the catalyst and make it safe for operation. Yeah, that should not be a major issue. And we use them in small amounts.
Yes.
Yeah.
Thank you, sir.
Thank you. Thank you.
One question on chat box.
Yes, sir. Yeah, I'll just pick up that. I'll pick up. This is a question posed by, if I read it right, Abarna. Yes.
Yes, sir.
Sir, the question reads like this: why using biofuels in vehicles? What about air pollution? Yeah, a good question. We do have similar magnitude of pollution associated with biodiesels as we have with diesel fuel. But still, as the biodiesel comes from a vegetable source and has a renewable feature, so that is how blending a little bit of biofuels is suggested. But somehow they are polluting, but we logically say that the pollutant, especially in form of CO2, gets back into the photosynthesis process, and then we claim that it would be a green fuel or something like that. But still, biofuels do have polluting feature. Some again, more research is required so that we can make them zero pollution fuel or something like that. But when used in an IC engine, the studies with respect to the pollution have indicated that they are in par with diesel in terms of the pollution. So therefore, some engine side modifications or research is required in order to address this particular issue. Yeah.
Hello, sir.
Yes, madam. Yes, madam.
Which catalyst is more preferable? Is it sodium hydroxide or potassium hydroxide with reference to yield of biodiesel? Is it related?
Yeah, madam, our study used sodium hydroxide as a catalyst, but I don't feel there is a major difference in terms of using KOH as the catalyst. I'm not much aware about using KOH, but literature suggests both are equally good as a catalyst. Again, I'll have to check with their associated cost and other things. May qualify one to be better over the other. Yeah, so my study does not cover this part of it. Please excuse me on that.
Okay, okay. Thank you, sir.
Thank you. Yeah, I have another. Okay, Harish, sir, there's another question there. Okay, while designing the experiments on biodiesel optimization process, what is a basic concept that we need to consider to decide lower and higher value of selected parameters with respect to the selected? Yeah, okay. Harish, it's about biodiesel optimization process. You state that we need to consider lower and higher values. Normally the text, the test what we conduct or the results what have been presented here are not based on one single test. So for a particular combination, we will be having say 6 to 7 trials made, and these 6 to 7 trials are going to show some variations, and these variations are averaged out. So whatever values have been presented are the averaged values taken up by the observations made over 7 to 8 trials, and based on that, yeah, that's exactly what, when we design a particular experiment, there's something called as a sample size for the required percentage of confidence level. So there is some statistical calculation based upon which for obtaining say 95% confidence level, so you need to have so many trials. So based on that, we will be deciding as to how many trials we should take. I hope I did answer your question, if I did interpret it properly. Harish, if you are there.
Yes, sir, I'm there.
Yeah, please.
Sir, basically, we're using design expert software to design the series of experiment.
Yeah.
That the number of trials will depends upon the number of parameter that we are going to vary.
Exactly.
So while if we are selecting catalyst, for example, I'm saying if we are selecting catalyst, there is a ranges and level values we need to decide. That is what is the lower range value and what is the higher range value. So within that, the series of experiment will be designed by the software.
Yeah.
So my question is how to select that lower value and higher value, on what concept that we are going to select that particular two values, sir?
Okay. So we also have some data what we get from the published literature also. Some experiments done on similar lines by researchers earlier, they give us some indicative value, or they share their results of what could be the probable limits between which optimum results can be obtained. So that can be one indicator. Apart from that, as you just made a mention, there is a statistical method based on design of experiments. We list out what are the different participating variables, or let us say for brake thermal efficiency, we are having the output power, we are having the RPM, we are having the torque. These parameters will affect the brake thermal efficiency. So now, based upon the required certainty of our results, or uncertainty if it has to be less than 2%. So then we fix upon how many trials should we be doing between the two extreme limits. So that is how we decided on choosing 3 or 4 parameters. Yeah, probably that's how we adopted a strategy, partly based upon the inputs we obtained from the literature, and again doing a statistical calculations which indicated what should be the right number of trials we choose for a particular experiment. Yeah.
Oh, thank you so much, sir.
Yeah. Probably I'll just do one small thing, like I'll share my email ID with the organizers. We can also have a discussion on mail. Yeah, I'd be glad to interact on this particular point.
Okay, thank you, sir.
Thank you.
I think
Yeah.
no more
Yeah,
questions.
I have one question. I think
I have 2 questions are there, sir.
yeah, sir. Did I address this?
Yes, sir.
Debajit Mishra has one question. In
Go
Indian
ahead.
context, which one would be the future plants to produce more biofuels, like our farmers cultivate rice or wheat? In Indian context, which one would be the future plant to produce more biofuels? Debajit Mishra ji, abhi, I think priority would be for the food grains. We should be exploring for biodiesels obtained from some waste sources, or it could be some agricultural residue which normally would go as a waste. So for example, we have rice bran oil. So once we take up the food part of the rice, the leftover husk also has a potential to produce oil. So normally the strategy should be to utilize the waste part, just as we have the waste cooking oil, and some residues which have potential to produce oil with some substantial calorific value would be what we would target. Definitely we would not be using rice or wheat to feed the biofuel stock. So priority would be definitely the food value of any commodity that we grow. Again, the scarcity of agricultural land would also be an issue. So I think a lot of policy matter would also be essential here in order to take a decision what should be our priority. Debjit ji, hope I did take your question properly, or I did interpret it. Yeah. Vikas has something, no major effect on by the basic catalyst. Yeah.
I think, sir, no
Yeah.
question. I think I concluding this.
Yeah.
Thank you very much, sir.
Yeah, it would be my pleasure for being part of this particular
Our
session.
pleasure to
Yeah.
accepting our invitation.
Okay. A lot of thanks for all the audience for being part of this particular session. I think such interactions should really serve the purpose of conducting ATAL. I think I've been attending a lot of ATAL programs which have been very informative. So I'm happy to be part of this particular deliberation. Thank you, sir.
Thank you, sir.
Thank you.
Thank you. Once again, thank you very much. Thank you all the participants. Tomorrow will be join 9 o'clock sharp sessions. Thank you very much, sir. Once again, thank you.
Sir, Sir,
Sir, yes.
shall I stop?
Stop, sir.
Yes, sir. Thank you, sir.
Stop
Thank
your
you
side.
once again.
Okay.
Thank you. Thank you.